every single time you send a message, load a web page, or stream a video, you're kicking off this incredible, invisible journey that happens millions of times a second all around us. Today, we're going to follow one tiny piece of data, one single packet, and see exactly how it travels the world. I mean, really think about it for a second. You tap send on your phone, and in what feels like an instant, your friend on the other side of the planet gets it. How does that even work? What secret path does that message take? Well, that's the mystery we're unraveling today. Okay, so to tell this story, we need a hero. And for our story, the hero is a tiny data packet. Let's just call him Packet. His adventure begins the very moment you type something and hit that send button. That's the spark, the moment Packet is born. Now, before Packet can even exist, 5 fundamental things have to be in place. It's like the basic recipe for communication. You've got the message itself, your text or photo. You need a sender, your phone, and a receiver, your friend's phone. You also need a transmission medium, which is just the physical road it travels on, like a fiber optic cable or Wi-Fi signals. And maybe most importantly, you need a protocol, a shared set of rules. Think of it as the language they both agree to speak. Without all 5, there's no conversation. So how does this data actually flow? Well, it can go one of 3 ways. First, there's simplex, which is basically a one-way street. Your keyboard talking to your computer is a perfect example. Then you've got half duplex. Think of a walkie-talkie. You can talk and you can listen, but you can't do both at the same time. And finally, there's full duplex, which is what we use most of the time. It's like a phone call where both of you can talk and listen simultaneously. So Packet is born, and the rules of the road are set. It's time to take the first steps of its journey. And this all starts in its immediate neighborhood, what we in the tech world call the local area network, or just LAN. You know, just like our towns and cities, networks come in all different sizes. Packet starts its life on a LAN. That's your Wi-Fi at home or the network at your college. If it needs to travel across town, it might hop onto a MAN, a metropolitan area network. But for the big trip, the cross-country or cross-continent journey, it has to get on the WAN, the wide area network. And the biggest WAN of them all? Yep, that's the internet. So within that local network, that LAN, the devices are all laid out in a certain way. We call these layouts topologies. Think of it as the local roadmap. A mesh topology is wild. Every single device is connected to every other device. It's super reliable, but crazy expensive. A star network is probably what you have at home. Everything connects to a central hub, like your router. Super easy to manage, but if that router goes down, everything goes down. Then you have older styles like bus and ring, which connect devices in a line or a circle. Each has its own way of managing traffic. All right, before Packet can leave its cozy little neighborhood and brave the vast wilds of the internet, it has to get ready. It's like packing for a huge international trip. You can't just walk out the door, right? For our data packet, this packing process is handled by protocols and a really important framework called the OSI model. So let's be clear on what a protocol is. It's the official rulebook. It defines the syntax, which is how the data should be formatted. It defines the semantics, which is what all that data actually means. And it defines the timing, basically when to send the data and how fast. It's the universal language that lets a brand new iPhone in India talk perfectly to a 10-year-old server in Brazil. And this brings us to that packing process I mentioned, the OSI model. The best way to think about it is like putting on a 7-layer suit of armor. Each layer adds a new piece of information, a new header, that prepares our packet for one specific part of its journey. This whole process of adding layers has a name: encapsulation. It all starts at the very top, with you at layer 7, the application layer. This is your web browser, WhatsApp, your email client, whatever app you're using. When you type that message and hit send, you are creating the raw data right here. This is where Packet is truly born. From there, Packet moves down to layer 6, the presentation layer. You can call this the universal translator. Its job is to make sure the data is in a standard format that any computer on the other end can understand. It also does other critical jobs, like encryption to keep your data secret and compression to make the files smaller so it sends faster. Next stop, layer 5, the session layer. This is the conversation manager. Its whole purpose is to open a dedicated communication line between your device and the other one. Keep that conversation going smoothly, and then, when you're done, close it down cleanly. It's like the switchboard operator for the internet. Okay, now things get serious at layer 4, the transport layer. This is the quality control boss for the whole trip. If your message is big, this layer chops it up into smaller, numbered packets. Then, on the other end, it's responsible for making sure every single one of those packets arrives safely and putting them back together in the correct order. This layer is the hero that prevents your file downloads from getting corrupted. Dropping down to layer 3, we have the network layer. This is the global postal service of the internet. It stamps our packet with its final destination address, the famous IP address. This address is logical, meaning it knows where the destination computer is no matter what network it's on. Then, this layer acts like a GPS, figuring out the absolute best path for packet to take across the entire internet. Now at layer 2, the data link layer, we zoom way in. If the IP address is the final city, the MAC address added here is the address of the very next intersection, the next router on the path. This layer is the local traffic cop. It's only concerned with getting packet from where it is right now to the very next stop, the next hop on its journey. And finally, we hit the road. Layer 1, the physical layer. This is where all that digital information becomes a real physical thing. This layer converts the packet's ones and zeros into electrical signals for a copper wire, pulses of light for a fiber optic cable, or radio waves for Wi-Fi. Packet is no longer just data, it's a physical signal racing across the world. Now here's a quick but important note. The 7-layer OSI model we just walked through is the perfect way to understand networking. But in the real world, the internet actually runs on a simpler 4-layer model called TCP/IP. It basically combines the top 3 OSI layers into one application layer and the bottom 2 into another. Why? Well, TCP/IP was just developed and put to use faster, so it became the practical standard. But don't worry, all the same jobs are still getting done. Okay, dressed in its layers of data and ready for anything, our packet is officially prepared. It leaves the local LAN, merges onto the global superhighway, the wide area network, and begins its high-speed journey across oceans and continents. One of the early superhighways packet might have used is called ATM, or Asynchronous Transfer Mode. Its genius was that it broke all data into small, identical-sized packets called cells. By doing this, it made the flow of data super predictable and reliable, which was amazing for things that needed a steady connection, like voice calls or video streaming. Another important technology was frame relay. This was a more budget-friendly way for businesses to connect their offices in different cities. It was clever. It used variable-sized packets and basically skipped doing its own error checking to speed things up, leaving that job to the computers at each end. It was all about efficiency. And of course, we have to talk about ISDN. This was a huge deal. It was a set of standards that basically upgraded the entire world's old analog phone system, which was built for voice, and made it capable of carrying digital data. This was a critical step in turning the phone network into the data network we rely on today. So, let's just quickly recap Packet's wild ride. It was born from your message, right at the top in the application layer. It got dressed for the trip, getting wrapped in 7 layers of instructions. It navigated the local streets of the LAN and the global highways of the WAN, using its addresses as a map. And finally, it arrived, where it was unwrapped layer by layer until your original message was revealed, safe and sound. And the most amazing part? That whole epic journey happens in a fraction of a second. It's an unbelievable high-speed dance of hardware and software that literally powers our modern world. It really makes you stop and think, if this is what we can do today, what are the data highways of tomorrow going to make possible? What kind of world will they build? Thanks for joining us for this explainer.